In this instructional video, we're going to finish our discussion of complex numbers by looking at the powers of the number I, the square root of -1. So what Rene Descartes came up with here, again, is his complex imaginary numbers behave like polynomials. So he went through this discussion and said that I to the first power, of course anything to the first power equals itself, is I squared, we have learned, is the number -1. I to the third power, he broke up into I squared times I, which would be -1 times I, which would give us -I. And I to the fourth power is I squared times I squared, because remember, whenever you multiply same bases, you add the exponents, which gives us -1 times -1, or +1. Now what Descartes came up with is he kept breaking apart these powers. These four repeated. So notice that I to the fifth is I to the sixth is -1, I to the seventh -I to the eighth 1. So this happens in patterns of 4 forever and ever and ever. So if you are asked for a power of I question, you are going to get one of these four answers circled now. You're either going to get I, -1, -I, or 1. So it says powers of I can be simplified using these facts. Now the easiest two to always try to get things in terms of is I squared, since you know that comes out of the real number -1, and I to the fourth, which comes out the real number +1. So always try to break things down into I squares and I fours. And here's what we mean by that. What if some dirtbag scumbucket gave you a problem with I to the 15th power and said simplify? Which of the four answers would you choose? Well, if you look down here at the bottom, if you start breaking things into fours here, you could say I to the 15th equals I to the 12th times I to the third. So I to the 12th power, remember, comes out +1, because it is I to the fourth, which is 1 raised to some power. So 1 raised to any power is itself. And then knowing the first four, I cubed is -1, gives us that answer. What if someone throws a negative exponent at you, Jan? Well, that's no problem. You could even take a negative exponent and say, well, that would be I to the -4th power times I to the first, would add up to give you -3. So I to the fourth raised to the -1, see, this is still going to be 1 raised to some power, is going to give you 1 times I. So in this case, there is one of your four answers. So your answers will always be I in one of these four. I squared -1, I cubed -I, because these happen in fours, I to the fourth +1. Now let's just do a few more here before I sign off this video here. Let's take a real nasty one here. What if someone gave you I to the 41st power? Well, if you start breaking that into fours, you could say that is I to the 40th times I to the first. And see, I to the 40th would really be I to the fourth power, which is 1 raised to the 10th power. So all of that would just be 1 times your I out here, giving you I. So remember, you will always get one of four answers here that repeat in patterns of 4 forever and ever. Let's try one more example here before we sign off. I'll give you a real nasty negative one here. Let's take I to the -92nd power. I mean, that's about as mean a nasty problem as you could get here. So if we're going to break this up, we could say that is going to be how many fours here? We can kind of go over here and go 4 goes into 92. Let's forget about the negative here right now. And that would be what? 4 goes into 9 twice, and you would get 8 here. 1 left over, 2, 23 times. Okay, so 4 goes in there 23 times. So this would be I to the 4th raised to the negative 23 power. What do y'all think? All right, but what is I to the 4th again? It is the number 1, and 1 raised to any power, positive or negative, is going to be 1. All right, so I hope this helped with the powers of I. Try to get them broken into I squares and I to the 4th, since you get real number results, and then whatever is left over is either going to be one of the 4 answers for the powers of I. Professor Young signing off.